Hey, welcome back. So now let's continue our vector table creation. As I said in the previous lecture, this is the initialized data. The initialized data will go to the data section. You have to instruct the compiler not to put this data in data section, rather in a different section, which we call it as a user-defined section. How do you tell the compiler to move this data into a different section? That you can do by using the compiler attribute. Let's go to the compiler documentation again, and here you have to go to variable attribute. Just search for variable attribute. Here it is, common variable attributes. And here you have to use section attribute, section name. Here it is. Normally the compiler places the objects it generates in sections like data and BSS. Sometimes, however, you need additional sections, or you need certain particular variables to appear in special sections. Yes, that is our requirement. We don't want to push that into data section. Rather, we want to push that into a special section. This is how you should use section attribute. Whenever you are mentioning any attribute in GCC, you have to use this prefix. That tells the compiler that you are imposing some attribute. After that, this is the syntax you have to use. Here, this is a variable a of type this structure, and the variable a is placed in this section. Compiler creates a section called duart_a, and it keeps that variable in this section. Special section will be created here. All right, you can see that they have used this right after the variable name. You can also follow this syntax. Let me just go back to my code, and here let's do that right after this variable name, or you can do at the end of the variable initialization also. Attribute, you have to open double parenthesis here, so let's do that, double parenthesis, and you have to give the attribute name section. After that, you have to again open the parenthesis to give the section name. Let's do that. Let me create a parenthesis here, and here give the section name. I would give .isr vector, or any name you can give. So here this dot is not mandatory. I have just given for the convention. This is not required. This is a section name. That's it. Let's see whether it compiles fine or not. Let me just run make all. Yes, it compiles. Or you can cut this and place this here at the end of this variable initialization here. That also should work. Let's see. Yes, it works. Now let's run the command none abi object dump -h startup.o. Here it is. We created a new section and its size is this much. That data didn't go into data section. This works, but I would keep this right after the variable name here. That makes more sense to me. Even you can use this section attribute with functions. For example, I can use the same attribute with this function reset handler. I can just give at the end of function prototype here. I can mention something like this. So now reset handler code is not placed in text section. It will be moved to ISR, or you can change this section name. Let's say some random section. You can see that before compiling, let's check the object dump. Text section was this much size, isn't it? And now let's do make. It went well. Let's check again. Here it is. A random section is created, and that code is moved here. You can see the disassembly here. Disassembly of random section. The code is moved to random section. Let me remove this. Now let's continue our vector table creation, and the next one is NMI address. Let's do that. Here, let me just create one more entry, and let's call it as NMI handler. NMI handler. Let me use this capital. We have to create the NMI handler. We just created the NMI handler, and let's add the prototype of this. Like this, you have to do for all 15 system exceptions and for 82 IRQs. That would be a tedious process. So would you create 97 such functions? That is not required actually, because in the program or in the application, the user or the programmer may not be using all the system exceptions or all the IRQs in the program. So he may be using few. That's why creating 97 such functions doesn't make any sense. That's why we can follow one shortcut. We can create a common handler for all the system exceptions and IRQs. Let me call it as a default handler. Instead of NMI handler, I'm going to create a default handler. And let's make this as an alias for all the exception handlers. For that, you have to use the GCC attribute weak and alias. What is a weak attribute? Weak is a GCC attribute lets programmer to override already defined weak function, or also called as dummy function, with the same function name. And the alias attribute lets the programmer to give alias name for a function. Let's use that. What I do here is I use the attribute with the NMI handler. Just watch this. It's very clear. Attribute, double parenthesis. So you just have to use alias. If you want to know the syntax of this attribute, you can refer to the documentation alias. Here it is. This is how you should use. You have to create one parenthesis, and that you have to give the name, alias name. Let's do that. Let's create one more parenthesis, and here let's give this name, default handler. Whenever you use the ampersand NMI handler, instead of this symbol, that is NMI handler, this symbol will be used. That means the address of default handler will be stored at this location, because this is the alias symbol for this symbol. What is next? So the next one is hard fault. Let's create the hard fault entry. Let me copy and paste this, and let me call it as hard fault. This also has the same function prototype. Whenever NMI exception happens, the default handler will get called. Here, let's simply hang here. This default handler doesn't do anything, just it hangs in infinite loop. And whenever a hard fault exception happens, then also this function will get called. That means this is a common function, or you can also call it as a dummy function. Now, as I said, this is a dummy function. How to implement a real function which handles NMI exception or hard fault exception separately? That is done by the programmer. What programmer can do is he can override this function in his source file, and he can write the real code there to handle the NMI or hard fault exception. That's why what you have to do is you have to make this symbol as weak. We have to use a weak attribute here. Making this as a weak symbol gives control for the programmer to override these functions. He can create a function with the same name without giving any weak attribute. In that case, it is like overriding this function. For example, in the main.c, what you can do is you can create your own NMI handler, and you can implement your real logic of handling NMI. Don't use any attribute here. Whenever NMI exception happens, control will not go to default handler. Why? Because this is attributed as weak. It goes to its real implementation, which is there in the main.c, let's say. That's why this symbol name and this symbol name, what you have used here, should be same. This is just the overridden function of this function. So now you have to create such prototypes for all the exceptions of the microcontroller and then populate in this array. That I will leave you as an assignment. What you can do is you can download a text file which I have attached with this lecture, and there I have mentioned all the prototypes of the exception handlers. Then copy that details into this source file and then update this array. I hope you can do that. And also you should note that whenever you are creating vector table, in the place of reserved, you have to put 0. That has to be maintained. This reserved space should be respected. You should create that gap in the array and put zeros there. I hope you can do that. I will see you in the next lecture.